All right, guys, so this is 3.8, meaning that our exam is coming up. Okay, a polynomial function. So graphing polynomial function is like putting together a puzzle made up of other functions. It combines the shapes of lines, parabolas, and cubes to make one mega function. Okay, all right, let's review some very quickly of the smaller shapes, okay, that we'll use to make one mega one. If you guys remember, a degree of 1 is going to be a linear. So a linear function is going to be a line. Just like this. It can be positive, it can be negative, but just like that. Now a degree of 2 is going to be a quadratic. A quadratic is going to be a U shape. It could be open upward or downward, but as you can know, it's going to be okay, so it could go upward or downward depending on our A value. Now degree of 3 is going to be a cubic, and a cubic is like a lazy S shape, okay? Another key element in polynomial functions is the end behavior. The end behavior is matched to the degree and the sign of A value. Since a picture is worth 1,000 words, let's sketch it out. All right, I want you guys to have 2 different color pens. So first it says odd degree. I'm going to give you 2 odd degree function. So the first one is going to be a linear and the second is going to be a cubic. So first it says A is bigger than 0. That means when A is positive. When A is positive, as you can see here, we can have a line having a positive slope. Just like the cubic, we can have a cubic function like that. These are just sketches, okay? Now, when A is negative, your cubic is going to have a reflection over the x-axis, so it's going to look like this, and your line is going to be having a negative slope. So as you can see, we're going to talk about the end behavior. The end behavior is just to the very end of the graph, to the very, very right or very, very left. Okay, so end behavior. As x students approaching negative infinity, I want you to pay attention here, okay? Negative infinity is over here, right? Negative infinity. What is happening to the y value? And as you can see, both the linear and the cubic function, y is going down. So this is down means negative infinity. How about as x is approaching infinity? Well, infinity, students, is over here to the right. Well, what's happening to y? The arrow is pointing up. So y is going up to positive infinity. So for odd functions, as you can see, x approaches negative infinity, y is going down for A being negative. Now let's go down really quickly. What happens when you have a reflection over the x-axis? When x is getting smaller and smaller, when we reflected it, y gets bigger. So that's positive infinity right there. Well, what happens when A is negative in the odd functions, right? I'm sorry, A is positive. What happens when A gets bigger? Y gets smaller. So that's a negative infinity. So it's not something that you should memorize. It's something that, hey, sketch it out. Sketch the parent, and then that way you can see where it goes. The end behavior is exactly like the name. Where does it go? Where does it end up at? Now, even degree, we so far have only studied the quadratic, but it's going to be the same. When A is positive, it's going to open upward, okay? When A is negative, it's going to open downward. So let's talk about the end behavior. And this is going to be applicable for all even degrees. When x gets smaller, and A is positive. Remember, this is positive A. Y goes up. So when x goes left, y goes up. So that's infinity. But the nice thing about this is that when x gets larger to the right, y also goes up. So even function, if A is positive, as you can see, y will always go upward to infinity. Now, if a is negative, this is a negative a. If x is getting smaller, y is down. X is getting larger, y is still down. So both of your y's are creeping down towards negative infinity when a is negative. In order to get an accurate graph, we also find and plot the x and y-intercepts. In order to find the x-intercept, students, as you remember, we let y equal to 0, right? And then to get the y-intercept, we let x equal to 0. So examples 1 to 3 says sketch the graph of each. And before we sketch, we want to talk about some of the stuff we need to sketch. So it says the degree here. This function, f of x equals x times the quantity of x plus 8 times the quantity x minus 2 squared would have a degree of 4. Because there's one x right here. This right here has a power of 1 as well. So we have 1, a 1, that's going to be 2 x's, and then this is going to be 2 more, so this would have a degree of 4. Now, the degree of 4 would give us 3 turning points at most, okay? So at most, 3 turning point, 3 TPs. Now, how do we decide how many turning points we have? So the number of turning point, students, TPs, the number of turning points, it's always 1 less than the degree, okay? So if you have a 4th degree equation, then your turning point will be at most. At most does not mean that you're going to have all 3 turning points. That means you have at most. So that means you can have 3, 2, 1, and sometimes none. So what would be a turning point? So a linear would have no turning point because it doesn't ever curve back down. So next, let's talk about this one. A quadratic would have 1 turning point because it goes up and then it turns downward, okay? A cubic function like this would have no turning points because it went up forever or down forever. And then sometimes you have a polynomial like this. So this one went down 1, up 1, down 1, up 1. So this is 1 turning point, 2 turning points, and then 3. So that's what turning points are. So think of it as the minimum or maximum. Our a value is going to be 1 because we don't see a number in the front. That means it's always 1. Now the end behavior is the newest piece here. Since your degree is even, your a is positive, we know all even degrees are going to look like a quadratic equation. So that means as x goes to the left, negative infinity, what is y? Y went up, so this is going to be up. Similarly, as x goes to the right towards infinity, look at this arrow. It went up, right? So that's also up. So this one, the end behavior, the y values are always going up. Doesn't matter what's happening to x. That is. Let's find the x-intercept really quickly. X-intercept, again, is when y equals to 0. So x int, y equals 0. 0 equals x times x plus 8 times x minus 2 squared. Now, x minus 2 squared, students, you can also think of that as x minus 2 twice, like that, okay? Now, it's already in factor form. If it's in factor form, then we can just take each factor and we set it equals to 0. So x equals to 0. Yes, we can totally have an x-intercept at 0. X plus 8 equals 0, x minus 2 equals 0, x minus 2 equals to 0. X plus 8 equals to 0, then that means the second intercept would be at negative 8. X minus 2 at 0 is going to be positive 2. Well, we don't write that out twice, so we're just going to write it once. So the x-intercept will be at 0, 0, negative 8, 0, 2, 0, and but 2, 0, students, we're gonna spell it out, multiplicity over 2, okay? y-intercept is when x equals to 0. So we can just do that mentally. If x is 0, 0 times anything, we don't care what these two things are, is going to be 0. So y-intercept is going to be at 0, 0. Now we have enough to plot. Okay, let's plot out all of the x-intercept. Yes, you should do that first. That's where we find them first. 0, 0, -8, 0, and 2, 0. Normally, I would say plot the y-intercept as well. But since the y-intercept is the same as one of the x-intercepts, then we're don't need to. Now, we know as x is negative, y is positive, and that x is positive, y is negative. So what does that translate for in our graphing? That means we use it as an end behavior. If x is negative, y goes up. X is positive, y goes up. That means we're going to run through the x-intercept. We loop up just like this, run through it. But here is the kicker. This right here has a multiplicity of 2, meaning that we do not run through that. Remember, we kind of studied the multiplicity before. We bounce off at this location of 2. That's what it means to have an even multiplicity. These right here had odd multiplicity, odd and odd. That means they had a power of 1. So a power of 1 will make the graph run through it, okay? So that's why we run through the -8, we run through the 0, but at +2, it was an even multiplicity. So we bounce it off and we loop back up. All right, guys. So example 2 says f of x equals x to the third minus 3x squared minus 4x plus 12. This is not in factor form, so just look at the biggest power. So this is going to have a degree of 3. That means we're going to have at most, students, at most 2 turning points, okay? Let's talk about turning points because I forgot to kind of bring it up. Turning points is kind of when do we turn? So we turn one time here. We went down, 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 and then we turn up. So right here is 1 TP, TP number 1. And then we went up and then we went down. So TP number 2 is right here. 2 or second TP, how about that? Second TP. Okay, and then we went down, then went back up again. So this is sort of your third TP. So that's why we said at most 3 turning points for a degree of 4. Think of it as your min and max location, okay? So turning points are when you can locate your minimum and your maximum locations. Now, for this one, we're going to say we're going to have at most. At most does not mean that we're going to have both. We might just have one, but at most we're going to have 2 turning points, meaning that it could be a 1 min, 1 max, or both mins, okay? Your A value is the value in the front, which happens to be 1. Since it is a degree of 3 and it's an odd function, we know it's going to look like a cubic, okay? A positive cubic without any reflection. So that will allow us to say, okay, well, x is going to go left, meaning that my y is going to go down. So that's going to be -infinity. That helps us sketch. Over here, if x is over here, that means I'm going to end up down here somewhere, okay? And then that's going to be similar to positive infinity. When x goes towards positive infinity, y goes up. So I'm going to go somewhere up like that. So those are the end behavior. Now we do have to find the x and y intercept for us to sketch out the rest. So x-intercept, we're going to take y equals to 0. So that's x cubed minus 3x squared minus 4x plus 12. Now this is factoring by grouping since there are 4 terms. So x squared times x minus 3, take out a -4. Now if you are struggling with factoring, please do come in and see me for extra support. Now these two are the same, so it's going to be x minus 3. And then we have an x squared minus 4. Remember, we're trying to solve for 4x. This is going to be factorable further since that is a difference of square terms. So I'm going to use 0 equals, drop down my x minus 3. That's going to be an x plus 2 times x minus 2. Yes, by this time in your math career in Algebra 2, I am expecting you to be able to factor just like that fast. Take each factor and set it equal to 0. So 0 equals x minus 3. Next is 0 equals x plus 2. Next is 0 equals x minus 2. Then if x minus 3 equals 0, then x has to be 3. Then this one has x has to be negative 2. Then this one has x equals 2. So we have 3 x intercepts. Let's write it in. 3 comma 0, and then negative 2 comma 0, 2 comma 0. Okay, y-intercept is just gonna plug 0 in for y, but as you can see, this is in standard form, so all x's would turn to 0. So this right here is immediately your y-intercept, that very last constant. So we don't even have to do any math. 0 comma 12. So plot those 4 in. Did we forget to write down the end behavior here? I think we meant to say positive infinity, right? All right, so let's plot it. It's 3, 0, negative 2, 0, 2 comma 0, 0, 12 for the y-intercept. So go all the way. That's 10, 11, and 12. Yes, do not be shy. Go all the way up. Make extra grids. Okay, let's check it out. Remember, none of this had repeating x-intercepts, so none of it was an even multiplicity. So we have to cross through all of our x-intercepts. So earlier we talked about starting below. So I'm going to erase that because now that I have actual points, I need to cross through this. I need to make it a little bit skinnier. Run through the y-intercept. I'm going to run through this, up, that, and then whoop, just like that. Example 3 states g of x equals x to the third minus 3x squared minus 4x. Now we do know the degree here because it's not in factor form. So when it is not in factor form, then we could just look at the term with the largest exponents. In this case, it is 3. That means we have at most, students, 2 turning points, 2 TPs, okay? That's, all right, a value. Since there is nothing in the front, it is always 1. Let's look at the end behavior. Since we have an odd degree, then immediately think of your cubic function, right, with the positive a. So an end behavior said as x goes to the left, y goes down. So down means negative infinity. As x goes to positive infinity, which is to the right, y goes up. So that's positive infinity. To find the x-intercept, students, we do need to factor it out. To factor it out, the GCF is an x. So now we have x squared minus 3x minus 4. Then the following step, we need to factor that trinomial a little bit further. Now, at this time, you do need to make your x, or however you choose to factor, you need to be able to get here fast, okay? Then from here, we are going to take g of x and set equals to 0, because when we are solving for x-intercept, that means take each factor and set equals to 0. So first, x equals to 0, x minus 4 equals to 0, then x plus 1 equals to 0. Then x equals to 0, that's 1 x-intercept. X minus 4 equals to 0, your next intercept is at positive 4. Then x plus 1 equals to 0, then your next x-intercept is x negative 1. So these are the 3 x-intercepts, and we are going to write that down. Okay, so 0, 0, 4, 0, and the last intercept is negative 1, 0. The y-intercept, it's in standard form, as you can see from here, but we don't have a constant at the end. So when we plug in a 0, all of these terms will turn into 0. So the y-intercept, which is going to be 0, 0. So to sketch this out, we will start with the x-intercept at 0, 0. That happens to be the y-intercept as well. Then we have another one at 4, 0, and then another one at negative 1, 0. We know the end behavior when it was down and it was up like that, right? So we're just going to connect the rest of these. Now each x-intercept, it did not repeat. So what that means, students, it's going to be an odd multiplicity. So an odd multiplicity, as you can see, we're going to go through all of these zeros and make a nice continuous graph. Okay, guys, so the next few examples are going to be graphing. We are going to teach you how to graph any function, okay? So the strategies are, first you want to look at the equation and decide, what kind of function is this? Is it a linear? Is it a quadratic? Is it a cubic? Is it higher than that, right? Then if you have decided, hey, this is a degree of 4 or 3 or 2, then you can say that, how many turning points can you have? Are there values that cannot be in the domain? So that means, are there going to be holes? If there are parentheses, plug in a number to make the expression inside 0, meaning that we want to see what the x value could be or what the x-intercept could be. From there, make a table of values to get some other order pairs if it's not enough for you to graph, okay? So here's example 4. 4 to 8 said, sketch the graph of the function given. State whether the function is linear, quadratic, cubic, absolute value, or polynomial. Answer the following characteristics. Write NA if it doesn't apply. So this is f of x equals x to the 4th minus 3x to the 3rd plus 2. Your degree here, students, is 4, so this is definitely a polynomial. So it said state it, so we have to state it. Okay, box that up. Then let's try to see if we can fill out some of the information before doing any math. So degree is 4, a value is 1. Number of turning points, it is going to be at most 3 turning points. That does not mean that we are going to have exactly 3. It means just at most, it can be 3, 2, 1, or sometimes nothing if it's a line, okay? The end behavior, since your a value is positive, that means it's going to behave like a quadratic, which is a parabola because the degree is even. So we don't even need a graph to say, okay, as x approaches negative infinity, which is to the left, y goes up. So that's positive infinity. Similarly, as x approaches the right side, which is positive infinity, y also goes up. So this is like that. X-intercept, we need to fill that out, but y-intercept, we can definitely fill this in without work. Y-intercept when x is 0, so both terms are gone, so now we only have the constant left to fill in. So let's plot that right away. We can even plot the end behavior. We know that as x goes to the right, y goes up, x to the left, y goes up, so they're both going upward, okay? Now x-intercepts when y goes to 0. Let's see if we can work this out. Actually, let's make a table and graph it out first. Is that okay? All right, let's make a table. Sometimes that will help us out. X and y. When x is, let's pick -1. We want to pick some positive values and some negative numbers, okay? All right, let's see. -1 to the 4th is 1. Minus -3, minus 3 times -1 to the 3rd. So that's going to be a positive 3 plus 2. So this is going to give us a value of 6. Now we can pick -2 to see what that would take us. So -2 to the 4th minus 3 times -2 to the 3rd plus 2. So all the basic math will come out to be 42. Well, that's really large. So what we don't want to do now is pick any more negative x. So we should try positive x's, right? We already have x equals to 0 because that's what the intercept is. So let's try 1. When x is 1, 1 to the 4th minus 3. So that's 1 minus 3. That's really -2. -2 plus 2 is 0. So now we can pick 2. And similarly, we can plug it in. 2 to the 4th is going to be 16 minus 3 times 2 to the 3rd is 8. 8 times 3 is going to be -24. 16 minus 24 plus 2, that's going to give us -6. Now I'm going to try to squeeze a positive 3 for x in here. And we're going to do the same thing, plug it all in. 3 to the 4th minus 3 times 3 to the 3rd plus 2, students. So this is going to come out to be positive 2. All right, let's just go and plot those dots, okay? I erased the green n behaviors earlier. So let's just plot these one, -1, up 6, -2, 42, that's way too large. 1, 0, 2, -6, 3, up 2, and then we had a y-intercept at 0, 2. We talked about the n behavior going upward on those. And so now we just want to connect the rest of these points just like that. Okay, so it's not a parabola, but it is all even power functions is going to behave just like that. All right, so we are going to see if we can figure out the x-intercepts without doing a lot of work. So we know one of it is right here. It's going to be 1, 0. We can see that it's hitting another x location. So that's 1, 2. In between 2 and 3. So let's just pick a value. Let's just say 2.5, 0. Now the reason we're doing 2.5, 0 is because this right here, students, it's a 4th power, and that's really not factorable right now because we haven't learned it. So right now, if it's not factorable in the 4th power, you can factor grouping, you can factor quadratics, just right now, not a trinomial with a 4th power. Example 5 is y equals an absolute value of x minus 7. So students, an absolute value is a special function where you're not going to have a degree. So the degree is going to be NA. But we still have an A value, which is 1. So I'm going to fill that in as 1. An H value, students, that's going to be your H, that's 7. We don't have anything adding or subtracting behind here, so that would be a 0. Okay. So even though we don't have a degree for this one, like I said, it's a special function, so we are still going to have a turning point, 1 to be exact. But let's graph it out first. When H is 7, so 7, and Y stays at 0, you do have a 1, so that's also your slope, okay? So this is your slope, which is in the absolute value, we call it plus or minus. So we're going to go up 1, right 1. We are also going to go up and left because we know it opens upward since the A value is positive. So I'm just going to connect these dots really quickly, make a nice V shape. So that means right and left will be the same. There you go. Okay, so here's a graph. Now the reason I said we still have one turning point because this is a decreasing and then this is an increasing. So this vertex is the turning point. So we have one turning point. And behavior, because it, as you can see, it opens upward. So it's kind of like a parabola. So x approaches negative infinity, which is towards the left, y goes up. So that's going to be up. And then when x approaches the right side, y also goes up. So that one, it's both are going to go towards positive infinity. X-intercept, we have 1 at 7, 0. And y-intercept, as you can see right now, looks like, because my line isn't perfect and graphing by hand is never perfect, so we might just want to solve for it. Y-intercept is when x equals to 0, students. So when I plug in 0, it's a -7. Absolute value of -7, it's just 7. So it's going to be 0, 7. Y equals quantity of x minus 2 to the third power minus 1. This is the cubic function in the HK form. So yes, we can graph this one super easy. A is 1, H is 2, K is -6. So the degree is going to be 3. So that means we're going to have at most 2 turning points. Okay, 2 turning points. A value is 1. Well, A is positive, so if we're talking about a cubic, it goes like that. So we can just feel out the end behavior immediately. When x goes left, which is -infinity, y goes downward, so that's -infinity. When x goes right, which is +infinity, y goes up, so that's +infinity. Let's make a parent table, students, for this. So it's going to be y equals x cubed. Let's graph it really quickly. The parent, -2 is -8, -1 is -1, 0 is 0 for the cubic function, 1 is 1, 2 is 8. And then we're going to use our transformation knowledge to make a new graph. H is positive 2, so that's going to be moving right by 2. And then K is negative 6, so we're going to take all the y and minus 6. So let's transform. Ready? Take all these x's and add 2. And so negative 2 plus 2 is 0. Negative 1 plus 2 is 1. Then 2, then 3, then 4. Then take all your y's here and then minus 6. Negative 8 minus 6 is now negative 14. And then negative 7, negative 6. 1 minus 6 is negative 5. 8 minus 6 is now positive 2. Let's plot. 0 is negative 14. That's easy enough for me to make 4 more tick marks. 1, 2, 3, 4. Right there is 0, 14, negative 14. 1 is negative 7. 2 is going to be negative 6. 3 is negative 5. And then 4 is going to be up 2. So as we predicted, the graph is going to be increasing because when x goes to the right, y kept going up. X-intercept, y-intercept. Y-intercept, we can feel that right away because that's 0, 14 from the table. But x-intercept, we don't know, so we do have to solve that manually. So it's going to be y is 0 equals x minus 2 to the third, to the third minus 6. Okay, first step, add 6 to both sides. So positive 6 equals x minus 2 to the third. So it's going to be a positive x-intercept again, right? So cube root. Undo power 3, cube it. So now, students, we have cube root of 6 equals x minus 2. Lastly is we're going to add the 2. Again, just like the other ones, we can say x equals 2 plus cube root of 6. That is your x-intercept. So we are going to write it in 2 plus cube root of 6, 0. Our example 7 says g of x equals 2/3 times the quantity x plus 5 minus 4. So this one has a degree of 1 since we don't see any power there. That means we have 0 turning points since it will be a straight line. This is going to be your slope, okay? We have an a value of 2/3, which is also meaning your slope. We have a point at h, k, which is going to be -5, -4. We can graph that right away by plotting the point and using your slope. So your -5, -4, your slope is 2/3, so go up 2/3, up 2, just enough so that way we have a nice straight line. Whoa, that was not up 2. So that's right there. Let's connect all of the dots. Okay, sometimes we are able to find the x-intercept quickly. In this case, that is one of those nice times. So that's going to give us an x-intercept of 1, 0. Your behavior as x goes left, y goes down. So that's going to be towards negative infinity. If x goes towards positive infinity, y goes up. So that's going to be positive infinity. Y-intercept, we do have to plug x in for 0. All right, so y, which is g of x, x is 0. That means you got 0 plus 5 is 5. 5 times 2/3 is going to be 10/3 minus 4. Students, 10/3, you can think of that as 3 1/3 minus 4, which is really 2/3. It's negative 2/3, my bad. It's all we have left. So that's about negative 2/3 right there. So 0, negative 2/3. All right, last example, h of x equals times the quantity of x plus 3 times the quantity x minus 1. So student, this is going to be a degree of 2, and we are going to have at most 1 turning point, 1 TP for turning point. The reason we know it's a degree of 2 is because this has a power of 1, this has a power of 1. When we FOIL this all out, we will have a degree of 2. A value is 1 since that is just number 1 in the middle. Since a value is 1 and the degree is 2, we know it is going to be a parabola. Now, as x goes to the left towards negative infinity, y goes up, so that's going to be positive infinity. Similarly to as x goes right, y also goes up. Okay, x-intercept, let's set y equal to 0. It's already factored out, so we're just going to take each and set it equals to 0. How nice is that, guys? So x plus 3 equals 0. X minus 1 equals to 0. So x equals to negative 3. And x equals to positive 1. So those are the two x-intercepts. 2, 2, 2, negative 3, 1. And we can write that in, negative 3 comma 0. And then 1 comma 0. Y-intercept, let's just plug in x equals to 0. So if this is 0, this is 0, it's going to be 3 times negative 1. That's just going to be 0 comma negative 3. Plot that in there. Based on your graphing strategy, when it is in this intercept form, we can plot it, and then we know the axis of symmetry is right in the middle. So that means we can make another dot here to make a symmetry with the y-intercept, and we need to find the vertex. X equals negative b all over 2a. That will give us our h value. And so that, actually no, ignore that. Sorry, that was from the standard form. The h value is right in the middle, so that's going to be negative 1. Then now we're going to plug this into the equation. Okay, plug it in to the y equals negative 1 plus 3 times negative 1 minus 1. So y equals 2 times negative 2. So that will give us a negative 4 for the vertex. So let's go down right there. Go up, and that's how we graph the intercept form.